Welcome to tonight's video on present value, talking about borrowing and repaying loans. Notice the present value equation here, which is one that I do not expect you to memorize, but you should know the variables and what to put in for what variable. When we talk about present value, we're talking about the total amount of money that you're borrowing, whether you're paying off a house or a car or anything that you basically take out money to borrow, whether it's on your credit card. The big R stands for the amount of regular payments you make, whether it's monthly payments or weekly. That's what you're going to have to determine from reading the problem. The R stands for the interest rate. Remember, you're going to convert that to a decimal. The K stands for the number of times it's compounded. When you're paying off a loan, usually it's monthly, but it could be weekly, so you want to read the problem. And the T is the number of years. All right, so what are the monthly payments or the regular payments if you have $1,200 that you're paying towards your loan every year, but the interest is compounded quarterly? Well, we would take 1,200 divided by 4, and you would get 300. If it was compounded monthly, then we take the $1,200 divided by 12, and we get 100. And if it was daily, we take the 1,200 and divide it by 365, and you get $3.29. So just like with future value, what we're going to type into our calculator remains the same. Y sub 1 is just the equation. Notice the difference here is that we only have 2 parentheses in the beginning for present value as opposed to 3 for future. And then the present value, or the amount that you're borrowing, is going to be your Y sub 2. And here are the rules as far as what your X maximum and minimum values are, depending upon what you're solving for. If you're solving for the regular payments, you're going to take the present value divided by the number of payments and multiply that by 2. Just like we did with future value, except here we're multiplying by 2 because the payments are going to be more than what it would be if we didn't have any interest. Your Y minimum is 0, and your Y maximum is always going to be double what your present value is. So now for the first problem. You purchase a $575,000 home with a 10% down payment. So $575,000 times 10% will give you $57,500. That's your down payment. That's how much you put down. You finance the rest, which means if you subtract from $57,500, you owe $517,500. That's how much you owe. So that is going to be your present value, $517,500. We don't know our monthly mortgage payments. We know our rate is 0.053%. It's 30-year loan, and it's being compounded monthly. So our Y sub 1 is going to be X, and then 2 parentheses, 1 minus parenthesis, 1 plus 0.0535 divided by 12, and then it's raised to the negative 12 times 30 power. Let me get rid of those right there. Divided by, and then parenthesis, 0.0535 divided by 12, and then you need 2 parentheses. Your y sub 2 is your present value. And then your window, well, your x maximum is going to be x minimum is going to be 0, and then x maximum, you're going to take the present value divided by k times t. So basically, in this case, 517,500 divided by 12 times 30, which is 360, and that gives you 1,438. But that is if you didn't pay any interest. You are going to pay interest, so I would double that. So I would make my x maximum around $3,000. Your y minimum 0. Your y maximum, I'd make $1 million in this case. And there you have your window. So then when you type that in, all you need to do is go second trace, intersect, enter 3 times, and you will get your value. So when you type it in, it should look like this in your calculator. When you graph it, you'll get the intersection there. So you go second trace, intersect, enter, enter, enter. And you get your loan payment of $2,889.80. So that is going to be your monthly mortgage payment. So remember, the actual amount you paid for the home, well, you paid a down payment of $57,500. You're going to make 360 mortgage payments because that's 12 payments a year for 30 years. The total loan payments, when you multiply $2,889.80 times 360, that gives you $1,042,000 approximately. So that gives you $1,040,328. But if you add that to 57,500, you get 1,097,828. That's how much you actually paid for the house with the loan and the interest. All right, so last problem here. In this one, notice you're paying $26,575 for the car with 0 down payment. You want to know what interest rate is what interest rate will be compounded monthly that will allow your payments to be under $460 a month, and it's over 66 months, so that's 5.5 years. So your y sub 1 will be 460. All right, so when you type it in your calculator, there's your y sub 1 when you put it in the equation. Y sub 2 is your present value of $26,575, because remember, you didn't put anything down, so you still owe the whole amount. And your window is going to be from 0 to 1 because you're trying to find a rate, and then 0 to 60,000 because you double the present value. So when you graph it, it'll look like this. So you get your intersection. At 0.0488. So when you round that, you can get 4.9%. And that will be your interest rate that you need to get these amounts. So your assignment for today will be to do the coursework number 12, 1 through 9 odd.